Hello. Today, I'm going to show you how to factor a quadratic by guessing and checking. To do this, we're going to think about factoring like the distributive property in reverse. We'll find different combinations of factor pairs, we'll test them, and we'll find the one that works. So, let's consider that quadratic right there. The first thing that I want to do anytime I'm factoring something like this, I want to look to see if there is a greatest common factor in the three terms in my quadratic. If I can do that, if I can find a greatest common factor in those terms, the numbers that I'm dealing with are going to be smaller after I factor that out. So it's going to be easier to manage. What I'm going to do, I'll look at this. It looks like the greatest common factor there is 6. So I found my greatest common factor 6. Now I'm going to pull that 6 out of everything else. That's going to leave me with 10x squared minus 3x minus 18. Now that I have it factored, I'm just going to consider the quadratic on the inside there. And I'm going to imagine that I had two binomials that multiplied together to give me that quadratic. So what would that look like? Well, if I had the product of two binomials, well, I'd have a set of parentheses like that. The 6 would still be there. And then I would have a term here, a term here, a term here, and a term here. All I have to do if I want to go backwards is figure out what those terms are. Well, if I'm going to multiply those first two terms, doing the distributive property, those first two terms have to multiply together to give me that 10x squared. So it's got an x squared on it. That means the first two terms in my binomials are going to have an x in them. So let's put that in there. So I got an x here, I got an x here. But I have numbers in front of that too. The numbers in front of that have to multiply together to give me 10. So the possibilities for the numbers, the coefficients on those x's, have to be factors of 10. So what I'm going to do is I'm going to list the factor pairs of 10. So I've got 1 and 10. 1 times 10 is 10. Then I have 2 and 5. 2 times 5 is 10. And 3 doesn't work, 4 doesn't work, and then I'm back to 5. So the only possibilities for the coefficients on these x's are 1 and 10 or 2 and 5. So what I'm going to do is I'm going to test the combinations of those factor pairs to see which one works. But before I get there, let's think about these two numbers. If I multiply those two numbers together, what do I end up with? I end up with that negative 18. So the possibilities for numbers that are going to go in these slots have to be factors of negative 18. So just like I've listed the factor pairs of 10, I'm going to list the factor pairs of 18. It's going to be 1 and 18. Let's see, I've got 2 and 9, 3 and 6. 4 doesn't work, 5 doesn't work, then I'm back to 6. So the only factor pairs here that I have are those. So the possibilities for these numbers have to come from one of these factor pairs, either 1 and 18, 2 and 9, or 3 and 6. Now what I'm going to do is I'm going to look at different combinations of those things, and I'm going to try it to see if I end up with this original quadratic that I started with. So here's what I did. I went down through and I made a list of a bunch of different guesses. Like here's my first one. I've got my format right there. That's the target. That's the polynomial that I'm trying to get to. There's the factor pairs of 10. There are the factor pairs of 18. Right? So there's my first guess. Same thing. I got a second guess. I've got a third guess, and so on. You might have to do this multiple times before you find the right factor pair, and that's okay. So for the first set, why don't we do 2 and 5? So I'll put a 2 here and a 5 here. And then I'm going to pick one of the factor pairs over of 18. Let's try 2 and 9. So what I'm going to do is I'm just going to take that 2 and 9. I'm going to put a 2 here and a 9 here. Let's try that. The last thing I'm going to need is I'm going to need signs to go in between. The possibilities for those signs, to figure out what they are, I have to look at the last number in my original quadratic. The last number in my original quadratic is negative 18. That means one of these factors has to be positive, one of these factors has to be negative. Now we're going to have to test to see which one is which. So to start off with, let's just say we'll do a plus there and we'll do a minus there. Now I've built two binomials. Let's multiply them together to see if I get my original quadratic, that one right there. So let's do first two terms. That's going to give me my 10x squared. That's what I want. Then we'll do the outside term here. 2x times negative 9, that's going to give me negative 18x. Then we'll do the inside two terms here. It's going to give me a positive 10x. And then we'll do the last two terms here. That's going to give me my negative 18. That's what I want. All I have to do now is combine my like terms. And when I combine the like terms, I find out that those two middle terms give me negative 8x. It doesn't give me negative 3x. What I'm looking for is this term, this middle term, to be the same as that term up there. And it's not. What that means is this particular set that I tried does not work. And I got to find a new one. So let's try a different one here. We'll go on to my second guess. Why don't we stick with the 2 and the 5 for now? We haven't exhausted all the possibilities there. And actually, let's stick with the 2 and the 9 too. But instead of putting the 2 here, like we did last time, and the 9 here, let's flip them. Let's see what happens there. So let's put the 9 there and the 2 there. And again, let's test our positives and negatives. One of them's got to be plus, one of them's got to be minus. Now, I'm just going to check the outside and the inside here. Let's see the outside numbers. When I multiply these two together, I end up with, that looks like a negative 4x. Multiplying the inside together, that's going to be plus 45x. Combining those two things, negative 4x plus 45x, that's just going to give me 41x. 41x is not what we're looking for. This doesn't work. That right there is not the negative 3x that I'm looking for. Even if I were to switch those pluses and minuses around, instead of having that be plus, let's say that's minus, and we'll say that this one over here is your plus. All that's going to do if I change the signs is it's going to change, instead of having this be a negative 4x, it's going to switch that so it's a positive 4x, and that will be a negative 45. When you combine those terms, instead of having a positive 41, you'll end up with a negative 41x. All that switching those two signs do is it changes the polarity of your number. It just changes it from positive to negative or from negative to positive. But the magnitude of your number stays the same. So again, my second guess, well, that didn't work. Let's try something different. So instead of, well, why don't we keep with the, we'll stick with the 2 and the 5. We'll stay there. We haven't exhausted all the possibilities. But let's move away from the 2 and the 9. Why don't we try the 3 and the 6? We'll take the 3 and the 6, we'll put the 3 here, and we'll put the 6 here. And again, we'll just throw in some pluses and minuses here. We can always switch them again if we end up with the opposite sign that we need. And then we'll test our outside number. Testing the outside number, 2x times negative 6. 2x times negative 6 is going to give me, that's going to be negative 12x. And then you get the 3 times the 5x, that's going to give me plus 15x. Combine those together, and that gives me positive 3x. That's really close to what I'm looking for up here. I'm looking for that negative 3x. So what I'm going to do, that's a positive, I need that to be a negative. So instead of switching everything around, all I'm going to do is I'm going to take that negative, that positive there, turn that into a minus, and that negative right there, and I'll turn that into a plus. What that's going to do is it's going to change that negative to a positive, and it'll change that negative, that positive, to a negative. When I combine those two, now I have 12x minus 15x. That gives me my negative 3, which is exactly what I'm looking for. So this is actually the factored form of my original quadratic. But before we move on and jump to like the end part here, I want to check that. Let's take my original here. I've got 6 times 2x minus 3 times 5x plus 6. Let's do the full distributive property and see what we got here. So we've got first two, that's going to be your 10x squared. Outside, that's going to be plus 12x. Inside is going to be, your minus 15x. And your last, that's going to be minus 18. And that, yep, that checks out. That's 10x squared minus 3x minus 18. That's my original. If I multiply the 6 through, that'll work out. So my final answer, get rid of my check in here. My final factored form is 6 times 2x minus 3 times 5x plus 6. Look at that. I didn't even need a fourth guess. But if I hadn't found it in the third, I would just jump down to my fourth. And if I didn't find it in the fourth, I'd jump down to the fifth. You just keep going until you've exhausted all the possibilities. But looks like that right there is the factored form of our quadratic.